Right now in the Gulf of Mexico, scientists are watching something quietly build, and they want you to know exactly what it is and exactly what it isn't, because the difference between those two things matters enormously for how coastal communities should actually respond. It isn't a hurricane. It isn't even a named storm yet. What it is a stretch of ocean water running dangerously warm, sitting there waiting for the right atmospheric conditions to turn it into something far more serious. And meteorologists have learned the hard way that when the Gulf gets this warm this early, calm monitoring beats panic every single time. A lesson written directly into how forecasting has evolved over the past several decades. This isn't a doomsday video. It's an explanation of why the people who track hurricanes for a living are keeping such a close eye on this particular body of water right now, and why that quiet vigilance matters more than any single dramatic headline ever could. No storm has to actually form for this story to matter, because the real story here isn't about one system. It's about an ocean that's been quietly changing for over a decade, and what that change means for every single hurricane season from here forward. Let's start with where things actually stand this season, because context matters here more than almost anything else. The 2026 Atlantic hurricane season has been unusually quiet so far. As of this recording, only one named storm has formed all year. Tropical Storm Arthur, which made landfall along the Texas coast back in mid-June and didn't produce the kind of widespread devastation many feared heading into the season. Beyond that single system, the broader Atlantic basin has stayed largely suppressed, held back by a combination of Saharan dust plumes drifting across the tropics and unusually strong wind. Shear, sitting over both the Caribbean and the Gulf itself, two atmospheric ingredients that make it genuinely difficult for tropical systems to organize and strengthen. Wind shear, in particular, acts almost like an invisible hand tearing at a developing storm from different directions at different altitudes, preventing the kind of tight, symmetrical structure a tropical system needs to intensify. Saharan dust adds another layer of suppression on top of that, since dry, dusty air moving off the African continent tends to choke off the moisture and instability that thunderstorms need to organize into something more dangerous. Here's the part that deserves real attention, though. While the wider Atlantic has stayed quiet, meteorologists have specifically shifted their focus toward the eastern Gulf of Mexico, where conditions have started looking noticeably more favorable for some kind of tropical organization in the coming days. A shift in attention that itself tells you something important about where the real risk currently sits this season. Forecasters have pointed to a weakening cold front expected to leave behind pockets of unsettled weather, potentially allowing a broad area of low pressure to develop and gradually gain structure over water that's currently running significantly warmer than it should be for this point in the season. Exactly the kind of setup meteorologists watch most closely at this stage of the summer. If a system does eventually organize enough to earn a name, the next one in line for the Atlantic Basin this year is Bertha, a name that hasn't been needed yet this season, but sits ready the moment conditions actually align. If you're finding this coverage useful, go ahead and hit that like button. It genuinely helps this kind of storm tracking reach more people who need to see it. Meteorologist Britta Merwin, describing the current setup, put it about as plainly as you can. The necessary fuel is present. That's not an alarming statement on its own, and it's not meant to be one. It's simply an honest, technical description of the ingredients currently sitting in place, the kind of assessment meteorologists make constantly throughout hurricane season without it automatically translating into an emergency. Current model trends, as of this recording, are only showing a modest uptick in overall activity. Nothing that's currently raising major alarm bells among forecasters watching the region closely. But here's exactly why that quiet monitoring still matters so much, and why dismissing it would be a mistake. The Gulf of Mexico isn't just warm this year. It's been on an extraordinary sustained warming trend for well over a decade now, and understanding that trend is essential to understanding why any storm that does eventually form there carries more risk than an equivalent storm might have carried a generation ago. Starting around 2012, summertime sea surface, temperatures in the Gulf began climbing at roughly twice the rate observed across the broader global ocean. That trend has continued directly into the 2020s, with sea surface temperatures hitting record highs in both 2024 and 2025. As of mid-May this year, Gulf temperatures were sitting tied with the same date in 2024 for the warmest ever recorded, according to ocean temperature tracking, maintained by researchers at the University of Arizona. To understand why warm water matters so much for hurricanes specifically, it helps to think about what a hurricane actually is at its core. A hurricane functions essentially like a heat engine. It pulls thermal energy directly out of warm ocean water and converts that energy into the kinetic force driving its winds. The warmer the water underneath a storm, the more fuel that engine has available to burn, and the faster a storm is capable of intensifying once conditions allow it to start spinning up in earnest. Meteorologists sometimes describe warm ocean water as high-octane fuel sitting in a tank, ready to be consumed the moment a storm structure becomes efficient enough to draw on it. Cooler water, by contrast, acts almost like a governor on that same engine, limiting how much energy a storm can extract, no matter how favorable the surrounding atmospheric conditions might otherwise be. If this kind of in-depth weather science content is exactly what you come here for, make sure you're subscribed, because there's a lot more of this coming and you won't want to miss the next update. There's a specific feature of Gulf circulation that makes this warming trend even more consequential. It's something called the loop current. This is a powerful ribbon of warm water that flows up from the Caribbean through the channel between Cuba and Mexico, curling northward into the Gulf before eventually looping back southeast past the Florida Keys, where it transitions into what's known as the Florida Current, and ultimately feeds into the Gulf Stream. Moving at speeds around 1.8 miles per hour, the loop current ranks among the fastest ocean currents anywhere in the Atlantic, and it acts essentially like a conveyor belt, continuously delivering warm Caribbean water directly into the heart of the Gulf. Unlike the broader, more diffuse warming affecting oceans, worldwide, the loop current represents a concentrated, physically distinct stream of especially warm, deep water, meaning its influence on any given storm can be dramatically more localized and more intense than simply pointing to overall average sea surface temperatures across the Gulf as a whole. Sometimes, this current sheds large, self-contained pockets of especially warm water called eddies, which break off and drift independently through the Gulf, carrying concentrated pools of exceptionally warm water separate from the main current itself. These eddies matter enormously for hurricane intensity, and there's a well-documented, genuinely alarming example that illustrates exactly why. Back in 2021, a warm eddy that had broken off from the loop current helped fuel the explosive rapid intensification of Hurricane Ida as it approached the Gulf Coast on August 29th of that year. Ida strengthened dramatically in an extremely short window before making landfall, a textbook demonstration of what happens when a storm passes directly over one of these concentrated pockets of warm water at exactly the wrong moment. Ida ultimately made landfall in Louisiana as a powerful major hurricane, and the storm's rapid strengthening in its final approach left communities with significantly less time to complete preparations than they would have had if the storm had intensified more gradually and predictably, the way older, less thoroughly studied storms sometimes did. That specific 2021 eddy, researchers tracking Gulf conditions have noted, eventually drifted west, and as of recent tracking, was sitting roughly 200 miles south of western Louisiana, a detail that matters because these warm pockets don't simply disappear once they've fueled one storm. They persist, drift, and occasionally sit directly in the path of whatever tropical system happens to move through that same stretch of ocean next. Naval Research Lab imagery tracking these eddies over time shows them behaving almost like slow-moving, semi-independent bodies of water, drifting for months or even years after breaking away from the main current, which means the exact same warm pocket that fueled one historic storm can, in principle, still be sitting somewhere in the Gulf years later, waiting for the next system to pass directly over it. This is precisely the mechanism scientists are worried about when they talk about rapid intensification, a term that describes a tropical cyclone's maximum sustained winds, increasing by at least 35 miles per hour within a 24-hour period. Rapid intensification is genuinely one of the most dangerous phenomena in modern hurricane forecasting, specifically because it can transform a seemingly manageable tropical storm into a major, life-threatening hurricane in the same amount of time it takes most people to plan a single day off work. Forecasters have grown increasingly focused on this specific phenomenon in recent years, precisely because traditional forecasting models have historically struggled to predict exactly when and how severely it will occur, meaning even well-monitored storms can sometimes surprise coastal residents with a far more powerful landfall than initial forecasts suggested just a day or two earlier. Research examining the specific dynamics of the Gulf has directly connected this warming trend to elevated rapid intensification risk, with one influential study warning that enhanced warming along the northeastern shelf of the Gulf could greatly increase the chance of rapid intensification, specifically for storms making landfall across that stretch of coastline, a finding that has only grown more relevant as observed Gulf temperatures have consistently tracked at or above the levels that study originally flagged as concerning, years before this current season even began. It's worth being genuinely careful and precise here, because overstating the current threat would be just as misleading as ignoring it entirely. Recent seasonal forecasts, using NOAA's climate forecast system model, actually predict that Gulf sea surface temperatures during the peak of this year's hurricane season will likely fall short of the outright records set during the intense stretch from 2023 through 2025. In other words, this year's Gulf, while still running significantly warmer than historical norms, may not necessarily reach the absolute record-breaking temperatures seen in some recent years. That's genuinely useful context, and it's exactly the kind of nuance that separates careful, honest science communication from the kind of exaggerated, fear-driven coverage that tends to dominate social media the moment any storm starts drawing attention, where a single warm data point often gets stretched into a prediction of certain catastrophe, regardless of what the fuller picture actually shows. Longer term, though, researchers studying the underlying cause of the Gulf's warming trend have identified factors that go beyond simple year-to-year variation. Part of the dramatic temperature increase observed since around 2016 appears connected to a so-called Super El Niño event that unfolded during the 2015 to 2016 period, one of only 3 events of comparable strength recorded since the early 1980s, alongside similar events in 1982 to 1983 and 1997 to 1998. A 2026 research paper examining these Super El Niño events found they've historically been associated with broader climate regime shifts, and the researchers behind that study specifically flagged enhanced risks tied to these events occurring against the backdrop of continued global warming, essentially meaning today's version of this natural climate pattern is playing out on top of an already warmer baseline than in previous decades. Each of those 3 prior Super El Niño events left a measurable fingerprint on ocean temperatures and storm behavior across the following seasons. And researchers studying the current climate landscape have been careful to note that a pattern which once represented a temporary cyclical spike in ocean warmth now unfolds against a permanently elevated global baseline, meaning even a return to historically normal El Niño conditions no longer guarantees a return to historically normal ocean temperatures. There's also a genuinely interesting wrinkle in how researchers expect this specific warming trend to eventually evolve. Scientists studying the mechanics behind the accelerated Gulf warming believe the unusually strong transport of warm water through the loop current, one of the key drivers behind the past decade's rapid temperature increase, may not continue indefinitely. Researchers predict this particular effect could begin winding down within roughly the next decade, which would gradually reduce the volume of warm water being funneled into the Gulf and bring its warming rate closer in line with the broader global ocean average. If that prediction holds, the current period we're living through right now may represent something closer to a peak in this specific warming mechanism, rather than the permanent new normal some might assume it to be. None of that longer-term nuance changes what's happening in the water right now, though, which brings us back to why this season's monitoring matters, regardless of how quiet the broader Atlantic has stayed so far. The National Hurricane Center designated its very first area to watch for potential tropical development back in mid-June, identifying the Bay of Campeche, in the southern portion of the Gulf, as a region where a broad area of low pressure could potentially organize. At the time, forecasters gave that specific system fairly low odds of actually developing, since conditions were only minimally conducive before the disturbance was expected to move inland over Mexico, though there remained some chance it could re-emerge over the northwestern Gulf and interact with an approaching frontal boundary. Even systems given fairly modest development odds still receive close, continuous attention from forecasters throughout their entire lifespan, precisely because the Bay of Campeche and the broader western Gulf have historically served as a reliable incubator for storms. During the summer months, when warm, shallow coastal waters provide exactly the kind of environment tropical disturbances need to gradually organize before drifting northward toward the U.S. coastline. That pattern, systems forming with initially low odds, drifting through the Gulf, and occasionally finding just enough favorable conditions to organize further, is exactly the kind of scenario meteorologists watch closely throughout the entire season, precisely because the Gulf's current temperature profile means even a modest, unassuming disturbance carries more raw potential energy underneath it than it would have carried in decades past. A system that might have fizzled out over cooler water in an earlier era now has a meaningfully better chance of tapping into enough warm water to organize, strengthen, and, in the worst-case scenario, intensify rapidly right before making landfall. This is also why coastal communities along the Gulf, particularly those in Texas, Louisiana, Mississippi, Alabama, and Florida's Gulf Coast, are consistently urged to prepare early in the season rather than waiting for a storm to already be organized and approaching before taking basic precautions. Emergency management officials across these states routinely recommend having evacuation plans, emergency supplies, and important documents ready well before the peak of hurricane season arrives, precisely because rapid intensification can compress the useful preparation window down to almost nothing once a storm actually starts organizing nearby. Rapid intensification, by its very nature, compresses the window between a storm looking manageable and a storm becoming genuinely dangerous, sometimes to a matter of hours rather than days, which leaves far less room for last-minute decision-making once a system is already bearing down on the coast. So circling back to where we started, Scientists monitoring the Gulf right now aren't sounding alarms, and there's a very good reason for that restraint. Careful, ongoing monitoring, tracking sea surface temperatures, watching for developing disturbances, running forecast models, continuously throughout the season is precisely the process that allows meteorologists to give coastal communities meaningful advance warning if and when conditions do eventually align into something genuinely dangerous, rather than reacting only after a storm has already become an immediate threat sitting just offshore. That quiet, methodical vigilance is the opposite of panic. It's the entire reason hurricane forecasting has become as accurate and as life-saving as it has over the past several decades. And it's exactly why a headline announcing that scientists are watching the Gulf closely shouldn't be treated as something frightening in itself. What actually deserves attention here isn't any single forecast or any single disturbance drifting through the Bay of Campeche this week. It's the underlying trend sitting beneath all of it, a body of water that's been warming at twice the global ocean average for, well, over a decade, creating conditions where any storm that does eventually organize there carries a meaningfully higher chance of intensifying explosively before making landfall. Scientists aren't just watching for the next named storm, they're watching an ocean that's fundamentally changed the risk calculus for every hurricane season that follows, and understanding that shift calmly and clearly is exactly the kind of preparation that keeps people safe long before any storm ever gets close enough to see on the horizon. That's ultimately the real takeaway, buried underneath every quiet monitoring update. Coming out of the National Hurricane Center this week. The absence of a major named storm right now doesn't mean the underlying risk has gone anywhere. It simply means the atmosphere hasn't yet provided the final ingredient needed to turn warm water into an organized system, and forecasters, watching every available data point, remain ready the moment it does.